All right, this is from, let me look up the date here for you. This is Wednesday, so this is 1/6/21, section 4.2, I believe it is. The first thing you need to know in this section is the names of the different types of polynomial functions and how we define what a degree is. So let's first define degree. Degree is the highest exponent in the polynomial. Okay, based on that degree, you can give its type. So if it's degree 0, it's called a constant function. If it's degree 1, it's linear to quadratic. 3 is cubic, and 4 is quartic. A lot of students are having a hard time with this word quartic, quartic. And then the other one that's difficult is if it's an x squared for the highest degree, highest exponent, then it is quadratic. And so here's some examples of each of these types. Okay, in this case, it's just -14. It's a constant. There's no variable in it at all. Here it is, the second one here, this is an x to the first for the highest exponent, so that's why we call it linear. Then it's the highest exponent, x squared, quadratic, highest exponent, so this is degree 3 is 3, so it's cubic. Degree 4, so it's quartic. So we're only worried about that highest exponent. The other thing, in order for you to be a polynomial function, is any exponents you do have, they've all got to be greater than or equal to 0, so you can't have any negative exponents. And so let's write that down. No negative exponents. And the other thing is no variables in denominators. Okay, and so you can't have something like f of x equals 3x squared plus 2 over x. That's not allowed to have an x in the denominator. That actually, the reason you can't is that actually implies a negative exponent. That's just a way of writing a division. So x to the -1 is the same as 1 over x. So we can't have any x's in the denominator. And then the last thing you need to know about this little section is that we want to put things in standard form. And standard form simply means you want to go from the highest exponent down to the lowest. So quadratics will go with 2. Then the next exponent would be a 1 if it has an x to the first, and then no x's in the last one. And cubics generally would go 3, then 2, then 1, then no x at all. And 4, then 3, then 2, then 1, and then no x's at all. So standard form just means you go from decreasing the highest degree of the polynomial function all the way down to the lowest degree. And you can just skip over any that aren't present. So you could have one like number, or like this cubic. It goes 3, 2, 1. It didn't have a constant at the end, but that's fine. Or you could have one like this quartic. It goes 4. There's no x cubed. There's no x squared. That's fine. The next highest is the 1, so that would go next. 2x to the first, and then -1 at the very end. So that's what standard form means. So 3 things you kind of need to get out of this is how do we tell the degree? Highest exponent. Then based on that highest exponent, what do we name it? Okay, so those are the names you got to know. And then how do I put it in standard form? And so we're going to take a look at each of these concepts. Okay, so this is our assignment from, let me get the date here correct for you guys, because I'm trying to go back, help you guys out. So this is from 1/6, January 1st. Okay, and so these are the notes that I covered in class, and this should help you with your assignment from that date in case you are behind us and answer a few questions. First example here is identify the polynomial function. So all we're looking for is, hey, all our exponents, are they positive or non-existent? And make sure we're not dividing by a variable at all. So let's check our exponents on number 1 here. We got a 3. The exponent, when they don't show it on an x, is just a 1. And then there's no variable on the last one. So that certainly that thing is a polynomial. Yes, it is. And standard form, does it go from highest exponent down to lowest exponent? And it does. So that is standard form. Let's state its degree. This is a degree of highest exponent, 3. Just stealing it from right there. Its type, that's where we name it. So its type, we call it cubic, just using that table that we just looked at. And the lead coefficient, the coefficients are the numbers that are multiplied by the variables. So we've got a coefficient here, -2 times the variable, and we have a coefficient here. The lead coefficient is just the first one. So in this case, it leads with a -2. Let's look at B here. Problem B, or question B, however you want to look at it. G of x, and we can see it right up here. On your paper, I would rewrite that if you were doing a problem like this. Let's see, let's check our exponents to see if we even have a polynomial. Yeah, 3, that's okay. 4, that's okay. And then our constant. So yeah, all our exponents are nice and positive. Now let's put it in standard form. The highest exponent term goes first. Well, the highest exponent is this term with the 4 in it. You don't have to add or subtract anything. You just slide the root 2 x to the 4th to the front. And then next comes the cubic term, because that's the next highest, -0.8 x cubed, and then our constant at the end. So it goes 4, then 3, then none. So there we go. It is a polynomial, so we should put yes here. The degree, highest exponent, degree is 4. That means when we look at that table, the type is quartic. And then the lead coefficient, kind of a strange one in this case, but that number in front of x to the 4th is just a root 2. So that's our lead coefficient. Let me clear out some of this stuff so we have room for C and D. I think I can find a quicker way to do that. Hopefully, let's try that. There we go. Let's look at C here. Let's check our exponents. X to the 2nd. Oh, red flag. X to the -1. We can't have negative exponents, so not a polynomial, and we are done because we can't answer the rest of them because the others only apply if it is a polynomial. Let's look at D. Let's check our exponents. We got an x squared, nice and positive. Red flag right there. No, we didn't say anything about variables as exponents. They've got to be nice numbers. Exponents have got to be 0, 1, 2, 3, 4, 5. You'll never see an x to the 0 in problem A here. This is really 8x to the 0, but x to the 0 is just equal to 1, so we never show it. Okay, so D, not a polynomial. And we're done. Let's see if I can spell polynomial. Lots of further things. And that's pretty much it. Okay, we'll look at a few more here. Okay, but we can answer everything we need to know pretty quick. We check our exponents and we put it in standard form. Again, just slide stuff. The x squared has to go first. Then comes the -5x. It's the next highest exponent. There's a 1 on that. And then 7. So they're standard form. Its degree is 2. We can see it right there. When degree is 2, we call it quadratic. And the lead coefficient is -1.6. You don't put the x squared next to it. That's the lead coefficient. I think that pretty pretty much covers it. Let's see if we get any weird ones. This one's not a polynomial, so we're done. This one is a polynomial. Here's standard form. It would be q of x equals, let's see, the 3x to the fourth goes first, then the x cubed, and the minus 6x. This would be a quartic, fourth degree polynomial. Lead coefficient is this 3 right there. Okay, this is what your homework looks like. I'll just do number 1 here for you. Is it a polynomial? We check our coefficients. 1, yep. 3, that's okay. 2, that's okay. And then no variable at all. So yes, it is. Standard form. So we just rewrite it. Sliding stuff. Putting the x cubed first. 5x cubed. Then the x squared, negative 6x squared next. Then the x term third, negative 3x, and then plus 2. Their standard form, degree 3, highest exponent. That makes it a cubic. And our lead coefficient is 5. So that's what your answer should look like. Please just don't put yes, write it. Put polynomial, yes, standard form, write the function, write degree, 3, type, cubic, lead coefficient, 5. And that should get you through that. No problem. All right, that's it. Good luck.